Namaskar, Adab, Sat Sri Akal. How are you students? I hope that all of you are doing very good. Okay, so let's start the today's lecture. So if I will be discussing about what we have completed till now, we have seen about alternating current completely. Now we are into the final section of electromagnetism. We have seen electrostatics, we have seen magnetism as well. Now we are going to combine all both the things, and now we are going to analyze very short chapter, and very less portion is there in your syllabus about electromagnetic waves. Actually, we are going to study about electromagnetic waves. I've told you about electromagnetic waves before the starting of electrostatics as well. When we are about to start electrostatic, the first lecture of 12th syllabus that we started, at that time only I have told you about electromagnetic waves. How I have told you? Do you remember? Anyone remember that? Let's see what we are going to understand. Hi Rakesh. Okay. See, I've told you there in the first lecture only. See students, this is the summary that what we are going to understand in this complete year. What I've told you, let's suppose there is a charge. There is some charge Q. Let's take our favorite pen. There is some charge Q that is present. If this charge Q velocity is 0, that means it is at rest. What will be happening? Some electric field will be induced around that charge. That is what we have understand in the first lecture, and that covered the portion of electrostatics. In this complete big chapter, we have only studied about this thing only, that okay, if any charge is at rest, what will happen? Electric field will be induced around it, correct? Now in the second case, what happened? Then what we have did, we have started moving this charge with some constant velocity. We have started moving this charge with some constant velocity. Due to that, what happened? Due to when charge started moving, some current was coming, current electricity we have studied, and due to a moving charge also, there was a magnetic field that was induced into the loop, correct? Okay, yeah, applications of electromagnetic waves are very wide, Rakesh. Yes, you are correct. In your NCRT also, there is a table. Okay, in electromagnetic waves, it is a very short chapter. If I tell you about the overview of this chapter, it is very short chapter, but still it is, I will say, for me, from my perspective, it is one of the most important chapters. Still, if you are going for competitive exam, for board also, you know that what are the useful things, but for competitive exam, it becomes very important chapter. Reason is there. What is the reason? If I will summarize this chapter now, it will hardly take 15 to 20 minutes to revise this chapter. It will take hardly 15 to 20 minutes to revise this chapter. And in competitive exams, when you are watching the pattern in NEET and JEE, both I am talking about, it will for sure going to give you 4 marks at least. So what is the fault? Is it important for boards or JEE? It is important for both. The applications you have to study line by line. You have to study this chapter I am telling you about. But for JEE, it is, I think it is more important, because it is a very short chapter. You don't have to put that much of effort. Only half an hour is sufficient for this chapter if you are if you are learning the proper thing. No need to study about unnecessary thing. Only some tips that you have to remember about this chapter, and you will be able to solve all the previous year questions for electromagnetic waves. We have taken even a lecture, a marathon session we have taken, and even a specific lecture I have taken for JEE revision on our channel. It is present, that is for electromagnetic waves. In just 10-15 minutes, I have summarized this chapter, and I have solved nearly all the PYQs of last year in that lecture, and just on the basis of this, nothing extra special that I have taught in that lecture. Okay. No. If we are for physics, I can tell you for sure that just 10-15 minutes is more than sufficient. No need. I can. You can ask to sir, our chemistry sir. But for physics, I can assure you that it is easy chapter, one of the easiest chapter that you will be having. Okay. Only 25 minutes if you are doing the only studying a focus thing. Okay. No need to deviate into other things. But if you are doing focus study for electromagnetic waves, easily you will be able to sufficiently able to solve one JEE question, and it is more what else we need. This much of less effort, and it is also going to give you 4 marks. No one is asking, and compare it with some decent good chapters, and they are also if giving you 4 marks, then what's the difference? Why will we are going to leave this chapter? There is no point. So let's begin this chapter. And I was telling you from where this chapter got initiated. Yeah, now Rakesh, we are very soon going to launch our JEE Advanced revision program also, and we are solving Aerodoc questions also on our channel in one shot. Like yesterday, I have taken one question. So if you want any specific course, you can comment down and you can connect to our team. They will be guiding you for. Okay. they will be guiding you for the further course, how we are going to prepare. We have actually a specific batch. We are focusing for complete JEE Advanced program. We are having some students, our JEE main students who have cracked JEE Advanced exam. So we are focusing on them. We are planning a specific batch just after the board completion. Very soon we are going to launch that program also, and there will be only talking about specifically about JEE Advanced. It will also be, there is complete batch will be coming, Rakesh. There is no problem. As of now, we have just initiated that Dodo question to see how much it is effective on you all. Okay. So fine. Now let's start about from where this electromagnetic wave is actually coming. I will tell you all the important things. Yeah, it will be discussed. If you want, I will convey your message. You can connect to the team and you can discuss all your queries. From there, they will be guiding you for the rest of things, and any help if you want from the team, they will be providing you as well. So when we move this charge with some constant velocity, what has happened? It started inducing magnetic field. It started inducing magnetic field. Due to movement of charge, there was magnetic field, and of course there was electric field as well. But the third case, when we have moved, still it is moving, but this time acceleration is not equals to constant. Here what was acceleration is equals to 0, that means constant velocity, but here acceleration is equals to, you will have some acceleration, that means velocity is not constant. What is the thickness? Correct. Here what will be saying, that velocity is not equals to constant. That means now it is moving with some accelerated motion. It is doing some accelerated motion, and when it is doing accelerated motion, what will be happening? Some, of course, electric field will be generated, magnetic field will be generated, but along with that some energy will also be radiated, and this is called as what? And this is what we are going to understand, how much energy is generated, how the wave is going to propagate, how the electric field will be propagating, how the magnetic field will be propagating. All these things we are going to understand in this chapter. Okay. So this was the outline for this chapter. Now let's start. Firstly, we will start from Maxwell. Actually, Maxwell observed a very interesting thing, because what we were thinking about the innovations that were going on, that okay, if there is some current, of course there will be some magnetic field, because it was defined by Ampere's law. What was Ampere's law? B dot dl, line integration, is equals to mu naught into I, and we have always drawn a Amperian loop, correct? And we have seen, okay, due to that some magnetic field will be coming. That was Ampere's law. But Maxwell observed that Maxwell observation was very important. Sir, if it is same as mobile radiation, yes, electromagnetic waves, a lot of used are there. Okay. So what, see, firstly Faraday's law was simply E is equals to minus of d phi by dt, rate of, if you are differentiating the flux, you will be getting the EMF. That was simple. But what Maxwell observed, that have initiated one very important concept of displacement current. He have initiated a very important concept of displacement current. Now understand what was displacement current, and till now what we were studying. Okay. See, what we have till now what we are studying is called as conduction current. What is conduction current? Simply what we are doing here, we have taken the parallel plate capacitor. We have taken what? Parallel plate capacitor, and we have introduced a magnet near it, and some current was flowing, and so that magnet was showing that there is some deflection. That means, of course, there is some magnetic field is inducing due to the flow of current. That was very fine. Okay, that was the same thing that was told about from Ampere. But what Maxwell did, he have introduced a magnet in between. Okay, he have introduced a magnet in between, and he have taken an Amperian loop. Here you can see there is an Amperian loop made. Okay, and now when he observed with the compass needle, he observed that some deflection is coming in between the parallel plates also, and that was surprising thing. Why that was surprising thing? Because when you have drawn this Amperian loop, if you are writing the equation of Ampere's law, B dot dl, line integral, is equals to mu naught into I. That is that, and how you are writing it? Amperian loop, you will be always, how you have calculated for infinite long wire and these kind of things, integration of dl will become how much? 2 pi L, 2 pi out the loop that you are taking is equals to mu naught into net current that is coming inside. And here if you is conventionally it should be 0, because there is no current in between. In air, how you can have some current? It is a very obvious thing. Okay. because they were always doing the experiments, Arun. They were so curious to understand, because they just simple thing. You can also do that if you are so curious to learn about some new things. You can also do it. What he did? He have did nothing special. Initially, he have kept the campus needle here, and finally he have kept the campus needle here. That's it. That is what his observation. But how you are interpreting those observation is what making you great person. Okay. Normally, if there will be reflection, we will be just ignoring it. But that was a person who have noticed it and who have derived a lot of things from there. He have defined complete displacement current from this simple observation. Correct? Now, displacement current was an unimaginable thing. Like how it. If you want to attempt, there is complete contact. You can contact to our team, and there they will be guiding you for the JEE advanced preparation. Yeah, of course, if you want, there is a lot of students who are 24/7 preparing in our institute. They are staying here completely from morning till night. We are present here, giving them the personal guidance that they require. Okay, so if you want, you can contact. Yeah, you can come. Where do you live, anyways? So that we can connect to you. You can connect digitally as well. So you can contact to our team. Okay, they will be guiding you. Fine. Let's move further. So what you have observed, that when he have played this compass needle in between, still there was some deflection coming, and he was completely shocked. So how it is possible? If I'm saying you that in air, is there any current that is fluid? No, still, but there was some deflection was coming in the compass needle. So from there he have derived, they told that there are two currents. Firstly, one is the conventional conduction current that is flown through the wire, and in the wire, actually there is, in air there is no current, but he have given a term for defining it. That term was what? Displacement current. That term was derived as displacement current, and that was coming due to the change in electric field. Because when he was changing the electric field, that compass needle was changing its direction. So that's why he have now redefined this Ampere law, and that's what we study about Ampere-Maxwell's law. Ampere-Maxwell's law. Both the combinations are there. So what was the new law that I will tell you? Here is a complete theoretical thing that are given, that is sufficient required for your board exam, because we are concerned for your board results also. So that's why all these theoretical things are given. If you need, you can contact to our team. They will be providing these notes as well. So what was this was the conventional Ampere law, and I've told you the net magnetic field that should be coming should be equal to 0, but it was not coming. So what was the observation? He observed that, and he is given his own statement. Not only the current produces the magnetic field, but a changing electric field also produces a magnetic field. Not only current, but changing electric field can also produce a magnetic field. And from there he defined that concept of displacement current, and this displacement current was defined by him as written as epsilon naught d phi e by dt. Epsilon naught already you know permittivity, and what is d phi by dt? Rate of change of flux. But which flux? Magnetic flux or electric flux? Electric flux, because we are talking about electric field. That means he defined this thing as rate of change of electric flux. And the net new law that he have defined, Ampere-Maxwell law, he have made some changes, and then he have made the law. It was written as B dot dl is equals to mu naught I conduction current plus I displacement current. This was the new law that also you have to remember. And if I will further write it, it is written as mu naught conduction current can be simply written as dq by dt, and displacement current is written as epsilon naught d phi e by dt. So this is one thing that you have to remember, and in board exam if the questions are coming, you can write in this way. Okay, fine. So that is the explanation. That is by diagram also. Here it is given very good way, so you can have the more feel of this conduction and displacement current from here. Ampere-Maxwell law, I have told you. Here it is the final law that is given, Ampere-Maxwell law. There were some changes in the Ampere's law. So there are some properties of displacement current that you have to understand. Displacement current is not a conventional current. Okay, the conventional current that we study, okay, due to the flow of electrons there is a current coming in the opposite direction. That is the conventional current. Here we are not going to study that current. It only exists when there is a change in electric field, because we are defining displacement current in terms of rate of change of electric field, electric flux. Okay, so if there is a change in electric field, then only it will be described. Displacement current does not exist under steady state condition. If there is steady state, that means everything is going constant, then there is no definition of this displacement current will be there. The conduction current and displacement current together satisfy the property of continuity. Property of continuity was defined by Maxwell only. So both these currents together define the property of continuity. This much of things you can study for your board purpose. Okay, so one by one you can see all the laws. What is Gauss law? Let's quickly recap all these things. Gauss law was what? E dot ds is equals to qn divided by epsilon naught. That means area integral, E into area integral, that ds integration we call it as area integral, is equals to, how we write, 1 by epsilon naught times, if anyone have studied about Gauss law, it is very simple law, into, always we try to calculate what is the net charge coming inside, and a lot of derivations also we have seen in our videos, that a lot of derivations we have did from Gauss law also and from conventional method also by taking the elements. So we have discussed about both the ways. Okay, what is the conventional way and what is the from that manner from Gauss law. Okay, net magnetic flux through any closed surface is always zero. Net magnetic flux through any closed surface is zero. This was what? Gauss law in magnetism. When you are doing the surface integral in magnetism, it is always equals to zero. This was then it came for Faraday's law. Faraday's law, what? EMF was defined in Faraday's law. How much EMF is there due to the change in flux. If there is a change in flux, that means there can be change in. We have seen complete Faraday's law in complete depth. One lecture only we have discussed for Faraday's law as well as Lenz's law. Okay, what was the law? If there is a change in magnetic field, change in area, or change in the angle as well, that means you are changing. If there is a change in flux, it will be doing what? It will create it will induce a EMF as well as some current. Correct? The EMF and current will be induced, and how that will be induced, that was defined in Lenz's law, and collectively we have studied about both of them. What you have defined about Ampere's law, new Amperian law he have given, Ampere-Maxwell law, and he have defined the concept of displacement current, that was given by Maxwell. Here is a summary that is very beautifully given to you, so that at one place you can see all the things. Correct? Now, motion of a charge. See, this is the thing that I've explained to you before starting this chapter, that if charge is at rest, you will be saying what? You have studied about the complete chapter. That was a very massive chapter. I hope that you have studied it in complete depth. It's a very important chapter, foundations of electromagnetism. That was electrostatics. If there is a uniform motion, you will be having both electric field and magnetic field. But when you are having an accelerated charge, it will give you time varying magnetic field as well as electric field. Both the kind of fields you will be having, and as well as some energy will also be radiated. That will be that is what we are going to understand, that how much energy will be radiated also. Okay, and this completely is called as electromagnetic wave. A wave will be radiated, and I will tell you what will be the directions also, from the direction of propagation of wave, what will be the direction of magnetic field, what will be the direction for electric field that is going to be generated. Okay, see, accelerated motion of a charged particle. This is what the complete theoretical things that are given here. I am going to tell you the important things that you should know to solve any kind of question from electromagnetics. In the starting only I have told you that I will tell you that much of sufficient things from where you can solve any kind of questions, either for JEE, either for NEET, any exam, any competitive exam, CET also. We are focusing on CET also. So any kind of questions you will be understanding after watching this lecture. One more thing that I will tell you that you have to read from your side is NCERT. There is a table in NCERT about a lot of waves, like Arun have said about microwave. Okay, so what are the applications of microwave, how you can generate microwave? Okay, all these things, and about the scientists also, wavelength are given also. So you have to understand that table, because a lot of times I have seen a pattern that direct questions are coming from that table. So that is a very important thing you should knowing about the applications. And about the solving part, numerical part, don't worry, just at the end of the lecture you will be understanding all the things. And in the question series anyways we are going to discuss about that. Now see, here it is a very important thing. that direction of propagation of wave, magnetic field and electric field always propagates in mutually perpendicular direction. That means, imagine now, let's suppose this axis coming towards you is x-axis, this is y-axis, and this is, let's suppose, z-axis, that is going upside. Okay, so what I am saying, that if a wave is coming towards you, in x-axis, that means it will be the direction for electric field, and this will be the direction for which video you are talking about, Arun? So what I was explaining, let me explain and then I will answer your query. Okay, Alak Pandey, that is a different thing. That about that only we are going to have a live today. Okay, that video was removed. Okay, so we'll focus on our studies as of now, then we'll come to that as well. Okay, so what I was saying, that all these three will be always mutually perpendicular to each other. If a wave is coming towards you, electric field will be perpendicular to the wave that is coming towards you. And how we get the directions? We will be getting the directions by E cross B. Always do E cross B. It is going to give you the direction of propagation. E cross B. This will give you the direction of propagation. Now see, let's suppose here what is the case given, I will tell you. A wave is propagating in positive x-axis. And due to that, and how I can find, electric field is going in positive y-axis and magnetic field is going in z-axis. I am just telling you how wave actually propagates, how electric field and magnetic field will be oscillating. As of now, I am just telling you. After that, we will see about the equations also. So now do E cross B. What I am telling you, the direction of propagation can be founded by E cross B. How we do E cross B? Take your fingers in the direction of E. How we do always A cross B, cross product? I have told you a lot of times in complete mechanism to do cross product. Take your hands in the direction of E. Then show your palm to B. Here Z axis is coming towards you. E cross B. And curl your hand. Show your palm to B and curl your hand. What is the direction that you are getting? That is X axis. And I can say that the wave is actually propagating in which direction? X direction. Correct? So this way you will always be finding the directions. So there is the answer from our team, Arun, that I hope that you got it. Okay. So now let's focus on the studies. So how it actually propagates, I will tell you. See, this is the direction in which your wave is propagating. Okay. Now how your waves are actually oscillating, I am telling you, this electric field is oscillating in perpendicular direction in the vertical manner, and this magnetic field is propagating in, it will be oscillating in the Z direction. How it will be propagating? See, this kind of wave will be formed. If I will draw the wave, this wave is drawn in x-axis. And if I will be drawing the wave, how it will be propagating, because both are sinusoidal wave. If I will tell you about the general equation also, the general equation for E is equals to E naught sine of omega t minus of kx. Now if it is moving in if it is in positive direction, then it will be minus. If it is in negative axis, then it will be plus. That is also I am going to explain. And if I will talk about the in general, what is the direction for magnetic field? It is B naught sine of omega t plus of, let's suppose, k. So both, what I am trying to tell you, that both are sinusoidal waves. That means oscillations will be like that way. We are understanding waves, this sinusoidal waves from SHM, simple harmonic motion. Till now we are studying about these waves. And if I will draw the vibrations of magnetic field, it is vibrating in the Z axis. It is vibrating somewhat like this. So both are vibrating in perpendicular direction. A very beautiful diagram is shown here to make you understand. See how wave is propagating. It is propagating, this red color is showing you the vibrations of electric field, and this blue color is showing you the vibrations of magnetic field, and both are propagating mutually perpendicular direction. This way actually wave propagates. Wave propagates. Here it is drawn in very beautiful manner so that you can understand in 3D direction also. Okay. and it is moving ahead in the, as soon as your wave is moving ahead forward in the x direction, you mutually with that also your electric field will also be moving and your magnetic field will also be moving. So now if I've told you that how to find the directions as well. Now let's see about the equations. Here the complete diagram is represented. This is the diagram for electric field, this red one, and this blue one is representing the direction for magnetic field. I hope that this is clear to you. Now if I am talking about any kind of progressive wave, first time you have understood about in SHM, simple harmonic motion, usually we understand about progressive wave. Okay, so yeah, YouTube link is there, Arun, if you want to watch, so you can see what is the complete scenario. Okay, so any kind of progressive wave is given in this kind of term: y is equals to some function x plus minus t, and some, if there is some initial phase, that is phi, that is represented. Now what is the important things and what are the things that you can take from here? That is what I am going to explain you. Let's suppose a wave is there. Understand, a wave is there, y is equal to a sine of omega t plus of kx plus of phi. Let's suppose this is the scenario. So what are the things that you can take away from here? Because half of the questions of electromagnetic waves will be solved from here only. If you have understood this wave now, what is these terms, how it is written, half of the questions are done there only. What are the things, important things? This a is represented as what? Amplitude. Amplitude in a curve, if I will tell you, this is called as amplitude. From the mean position, the maximum height that is attained by the wave is called as amplitude. Okay. Then omega t. So what are the other things that you can take from here? If this sign here, what is the sign? This is positive. In front of kx, what is the sign? This is also positive. If both the signs are same, that means this wave is going to propagate in negative direction. That means this wave is going to propagate in negative direction. And what will be the direction now? Negative of what? X, Y, Z. All three directions are possible now. So that is represented by the coefficient of x. That means this is going to propagate in the direction of negative x-axis. And if you are watching, if anyone have seen the questions of JEE Mains previous year question, just by judging this much of only, nearly you can find the answers also. You can eliminate the option. This is more than sufficient data. If you understood this thing, that okay, my wave is going in this direction, some value they will give, the third direction already you can find just by doing cross product, because we know the relation also. What is the relation that we know? Direction of propagation, that is represented as C is equals to E cross B. Just do E cross B, you will finding the directions. Simply questions will be solved. See, now let's take one more example. Let's take one more example, because for students will say that it is not clear. Let's see one more example. Let's suppose y is given as some a sine of omega t minus of kz plus of phi, for example. Now if I will ask you, tell me what is the direction of propagation of this wave? Batao. What is the direction of propagation of wave? Can anyone tell me what is the direction of propagation? Comment. See, how will this wave will propagate? What is the first step? I've told you. Watch the signs here. Here what is the sign? Plus. Here what is the sign? In front of k, it is negative. Whenever these signs are opposite to each other, this is positive, this is negative, this wave is going to propagate in positive direction. When there is same sign, wave is propagating negative direction. When there is opposite sign, wave is propagating positive direction. That means this direction is positive. And how you will be judging? Let's suppose here not written x, this is, let's suppose z. That means positive direction is clear, but positive of what? X, y, z, something will be there na? So it is going to propagate in positive of z direction. Positive of z direction it is going to propagate. Clear? This way you will be judging. Now some basic, very basic terms that are present there. So let's see one by one so that you can write in your board exam as well. First thing is amplitude. Most basic thing, amplitude. What is the definition? See, maximum displacement of each particle from its undisturbed position. Undisturbed position, we know this position, the mean position, that is called as undisturbed position. In SHM also we have calculated this distance, that is called as amplitude. Wavelength lambda. Distance between two consecutive crest or trough is defined as lambda. Next thing, wave number. Wave number is defined as what? This let's suppose this kind of term is there. This distance is defined as wavelength lambda. Wave number is defined as 2 pi by lambda, or also it is defined as, sorry, it is represented as k. K is also written as omega by v. Okay, omega by v. What is time period? Time period for one complete oscillation. One complete oscillation from this time to this time. If this is t is equals to 0, what I can say about this time? This is t is equal to capital T. This is t is equal to capital T. That is a complete time period. Okay. Then what are the other terms? There is frequency. Frequency is what? Inversely proportional of time. It's a very easy thing. Angular frequency defined as 2 pi f, also defined as 2 pi f is equals to 2 pi by time period. Speed of wave, what is the speed of wave? You can define in terms of, here it will be written like this, it is not written by like, k is defined as 2 pi by lambda. 2 pi by lambda will be going here and it will be going in the numerator. That means 2 pi f into lambda and divided by 2 pi. This 2 pi will get cancelled out and it will become f lambda. And it is the relation from the basic classes we know, velocity is equal to frequency into wavelength. Clear? Phase constant, initial phase, it will tell you about at t is equal to 0 where your what is the position of your particle. All these things we are familiar with from simple harmonic motion only. Okay. See, now let's come to the equations. Now it will be real fun. How will be writing the equations? I have already told you. Let's suppose if it is given that E is equals to, sorry, what are the things that we have to understand from here? Here the equation is given as E is equals to E naught sine of omega t, sine of kx minus omega t. ये बताओ कि what is the direction in which it is going to be proportional? Intensity is defined as power divided by area. That is also what we are going to understand. And if you want to calculate intensity in electromagnetic wave, just multiply your energy density with c. That is the speed of light. Okay, you will be getting your intensity. Intensity you can understand very easily. Okay, let's suppose a small pipe of water is throwing some water on you. Okay, and you will be not have problem from it. But imagine that a dam water is coming towards you. See, what is the difference? What is the difference we are talking about? The intensity of water, intensity of light. All these things can be intensity with what wave are traveling. That is also defined. So intensity is a very general term. If you are asking me about the formula, intensity is in general defined as power divided by area. And here if you want to write intensity in this chapter, we always write energy density multiplied by c. That derivation also we are going to see. So here if I will ask you, tell me a simple question. What is the direction of propagation of wave? I think some error is there. Okay, we are again live. Is my voice is clear to all of you? In photoelectric effect also we talk about intensity, we talk about radiation pressure. In the topic of radiation pressure, actually we discuss about intensity, that how much the intensity with which it is coming. We are live now. Is in relation between intensity and energy. Yes, I have told you now that if you want to calculate intensity, how will be calculated in that? Just multiply your energy density by c. How that result is also coming, that we are going to discuss. What is the relation between intensity and energy, that we are going to understand. Okay, fine. One very important point that we have to remember, that phase constant, that phases that I have given you for electric field and magnetic field, both of them will be always remain same. So it is also an important point in eliminating the options in your objective exam, where you have to mark 4 options. You can eliminate a lot of options just by these basic things that till now we have not entered into any formula, but still we can eliminate a lot of things. Trust me, you can go after this lecture and solve the question. You will be easily understand the questions as well. Okay, try to practice, because without practice there is no point. So for direction of propagation, I have already told you it will be E cross B. And what is the relation between magnetic field, electric field, and velocity of light? It is defined as E is equals to B into C. These are the peak values, or also called as peak electric field, peak magnetic field. So these are the terms that you should be understanding. This is a basic relation that is present. One more very important relation about permittivity and permeability. Anyone know about the relation of permittivity and permeability? Both are the things about intensity, but luminous intensity we talk about light waves. Okay, that is the term that we always use in light waves. What is the relation between permittivity and permeability? is the relation that you have to remember. That is a very important thing. It is equals to 1 by root under mu naught into epsilon naught. Mu naught into epsilon naught. This is a very important thing that you have to understand. This is the relation about between permeability and permittivity. So if I am talking about any medium, if I am talking about let's suppose any medium we are entering, how we will be writing in that medium? You remember in electrostatics, if I am entering into medium, how I have written Coulomb's law? I have written F is equals to K, or K can be written as 1 by 4 pi epsilon naught into Q1 Q2 divided by R square, correct? And when we have discussed the same thing in medium it is written as K, or it can be written as 1 by 4 pi epsilon naught multiplied by epsilon R. That is the relative permittivity. That means what I have told you there, that epsilon is equals to epsilon naught into epsilon R. Epsilon is equal to epsilon naught into epsilon R. This is a very important result, and it was defined by K, Q1 Q2 divided by R square. So basically I have told you that just write the force into the air, divide it by the relative permittivity, you will be having a result. This is the only thing that you have to do. So here also, if you you have to calculate what is the velocity of the wave in any medium, how you will be writing? You will be writing UM and EM. What are the things? These are the permeability of the medium, and this is the permittivity of the medium. So how you can write that? Just write like this, multiplied by the relative permittivities. How you will be writing? You will be writing it as mu naught into mu R, that is the relative permittivity, and here epsilon naught into epsilon R. That is the only thing that you have to do, and some values will be given. Always you can find that. So this way you can calculate anything in medium also. Okay, this is what I have already explained you. Now let's discuss about the energy. That is what from that much time we are waiting for. Let's see how we get the energy and energy densities. Actually we talk more about energy densities in this topic. So how we define energy densities? Let's see. Okay, see, what is the potential energy stored in electric field in between the plates of a capacitor? How we define that? In that chapter you remember that potential energy is equal to half CV square. And what is V? The relation of potential with electric field is equals to V is equals to E into D. Using these two results that we have already studied, we are going to find our final result. How we can say that when electric field is propagating, because there is electric field also that is oscillating, so how much energy that is carrying. So what we are going to do, U is equals to what? Half C V square. And at the place of V, what we will be writing? At the place of V you can write V is equals to E into D. That means E square D square, correct? Now half. What I can write for capacitor? For parallel plate capacitor, what is the capacitance? Tell me the formula. What is the formula? It is A epsilon naught by D, correct? Multiplied by E square multiplied by D square. Clear? Now if I can solve it, D will simply get cancelled. What are the things that are left? Write it once. It will be half epsilon naught E square, and here it is what? A into D, area into length. I've told you a lot of times whenever we have did volume conservation and this kind of things also, area into length we always take it as volume. We always take it as volume. So what I can further write, and here it is energy divided by volume, we define it as what? Energy density. It will become energy density. So energy density is written as half epsilon naught E square. Energy density is defined as half epsilon naught E square. This is one important formula. Now this is the first formula that I have told you that you have to remember. Energy density of electric field is defined as half epsilon naught E square, and even you have studied about this formula in electrostatics as well. There also we discuss about this thing. Now if I'll ask you, tell me the average. That is more interesting. How will be calculating the average? For calculating average, what you'll be doing? Simply write the energy density that you have. Energy density representing, I am representing from ED. Now what is the general equation for electric field that you have seen? E naught sine of omega t. That means it will become what? E naught square sine square kx minus of omega t. Square it. Now what you have to do? You have to take the average. Kar lo average. Take the average on this side also, this side also. Now tell me, what is the average value of sine theta cos theta in complete cycle? What is the average value? Do you remember? Tell me. It is 0. And what is the average value of sine square theta or sine square omega t and cos square omega t in one complete cycle? It is half. Okay, so what will be the average value of this complete term? This is the important term, sine square kx minus omega t. This average value is going to give you half. That is the direct result that I have told you in current electricity. So make it half. What will be remaining? Already there is a half factor, that means it will become 1 by 4 epsilon naught e square. That is defined as what? Average energy density. So if you want to remember directly that multiply half factor in the energy density, you will be having your average, or otherwise you can derive it as well. There is nothing such tough thing. Okay, let's put it the same way. We are going to derive the energy density of magnetic field as well. It is a complete derivation that is available for you. Now let's see for magnetic field how we can calculate the energy density for magnetic field. So in inductor, if I will say how much energy is stored, that is equals to half Li square. Okay, so I am going to use that only, half. And what is the inductor of a coil? You can write it as mu naught n square A into L into I square. How you can write I square? I square, because you know the magnetic field in a solenoid is also mu naught Na. So from there I will substitute the value of I, and I will be written as, because there is I square, it will be B square divided by mu naught square N square. Correct? Now let's see, after calculating, what is the result that is going to come. Mu naught square cancel, N square cancel, A into L again going to give you what? Volume. That volume I am going to take here, and I am going to define this complete thing as energy density. Again, energy density, because energy divided by the volume is defined as energy density. So here what will be saying? It will be equals to B square divided by 2 mu naught. This is the formula for energy density in a magnetic field. B square divided by 2 mu naught. Again, if someone asking you, tell me what is the average, what will be the average value of this energy density? Again, you will be writing the same kind of thing, half. At the place of B, what you can write the complete equation, B naught sine of kx minus omega t. जब तुम इसका square करोगे, it will become B naught square and sine square. Again, when you will be calculating the average of this sine square kx minus omega t, क्या होगा उसका average value? Already we know the result. We have derived the complete result also. So why not that to use that result? Okay. So what is the result of that? It will become half. That means there is one more factor for half, and it is B naught square divided by mu naught. There is already. That means it will again become 1 by 4 B naught square divided by mu naught. These are I will say not 4 results. This is only 2 results that you have to remember. It will be fine for all your questions. Okay. Because बहुत बार energy density से questions आ जाते हैं, तो you should be knowing about it. Clear? Now some students were asking me about energy densities. How you will be writing energy density? See how we define energy density. Along with that, I am defining here what about the intensity. Intensity we have started from here. What is intensity? Intensity is equals to power divided by area. Simple as that. Power divided by area. And what is defined as power? Tell me, what is power? From where this power term is coming? It is defined as the rate of doing work. That means how we define rate. If I am defining anything, that means divided by time. That means how I can write power as well. Power can be written as energy by time. So you can write U by T into area. Correct? Now how you will be writing energy? We know the energy density formula, correct? Now we know about energy density. What is the energy density? Energy density, we defined energy density is equals to energy divided by volume, and that is equals to, let's suppose, half epsilon naught E square. That is what we have defined there. So if I have to write the energy, how I will be writing? I will be writing this energy is equals to half epsilon naught E square into volume. Half epsilon naught E square into volume. So now let's write the intensity. Intensity I am going to define as energy. How I am going to write? Half epsilon naught E square into volume. This is the volume. Okay. So कैसे लिखोगे volume? Volume we will be writing area into the length. Let's suppose I have taken a cylindrical shape. So I will be writing the cross section area as A. And how I will be writing this length? I don't know, the length is not given, so I can write if what is the speed of the electromagnetic wave. Speed of, okay, Ayan wants to try some singing, so we can welcome him to try singing in our live video. You are most welcome. How I will be writing that volume? I will be writing this length will be equals to what? What is the speed? Speed of light c into, let's suppose, and here time is given as t. So मैं क्या लिखूंगा? C into t, and it is divided by what? Initially I have divided by area. So what you are going to get from here, and it is divided by t also, because that is the complete of a into t. A will get cancelled, t will get cancelled. What is the intensity, students? You are going to get from here half epsilon naught E square into c. Exactly what I have told you. What I have told you, you don't have to remember the formula for intensity. What you have to do, if you have to write intensity, remember a trick, just multiply energy density with the speed of light, and that's it. You will be getting your intensity directly. There is no need to remember any extra result for this. Okay, you don't have to remember any extra result for the intensity. Directly you can write multiplying by energy density, attach it with c, you will be having the intensity. Simple. Okay, this is the relation that some students were asking, tell me about intensity. Okay, so this is the intensity that you will be. Mic is loose. I don't think so. Mic is complete tight. Hello. Now my audio is clear, Ayan. Okay, anyways, now this topic is going to be completed. So we have discussed all the important things majorly that we had from here. Electromagnetic spectrum, this is complete theoretical part, and it is completely explained in your NCERT book. Once open your NCERT book, okay, once open your NCERT book, there is important tables, and one by one it is described about all the waves, all the electromagnetic waves that are present. Gamma rays, X-rays, ultraviolet rays, visible rays, infrared rays, all these waves are present. And read about the generation, how they are generated, what are their applications, where we do use them, and this that table is very informative, and directly questions can come from there. Even in your board exam, if someone is asking you to explain any wave, you should be knowing about those waves. Okay, scientists' name are also mentioned, so you should be understanding about all those things. Now we have completed the electromagnetic section completely. Finally, we have completed electrostatics, electric part, magnetic part, and from tomorrow we are going to start, from next class we are going to finally starting the most interesting part. I will say there is a very less need of remembering any formula. I will tell you, there is nothing like the basic formulas that you have studied in 9th, 10th. We are going to start from that level. Okay, that is very interesting part that we are going to starting from tomorrow. That is geometrical optics, and even after that wave optics also we are going to study. So this is the major part that is we are going to start from our next class. So till then, keep learning, keep growing with Tapasya, Endigu and Endigu Nama Tapasya.